this lesson we are doing the second part of the presentation station for quadratic functions, an introduction to quadratic functions, chapter 8. In the book we're on section 8.1. And we are doing a very quick warm-up for this next section. And what our warm-up says here for number 1 is to evaluate x squared for plus 5x. And what they're telling you is for when x equals 4 and when x equals 3. So that means you're going to have to do this 2 times. So one time x equals 4, and on another time x equals, it's negative 3. And so when it says evaluate, that means we're going to take this expression, x squared plus 5x, the same expression on both sides. The reason I'm doing them next to each other back to back like this is to show you that you actually have to do the problem out for as many things as they give you for x equals. And so here, if x equals 4, well, instead of having x here, I'm going to put a 4. It's called substituting. I'm going to substitute x with the 4 and keep the squared plus 5. And again, here's another x. So I'm also going to substitute that one with a 4. Now I put times in the middle of it because 5x together, coefficient and variable, that's times. Stuck together means times. And so I represented it this way with a dot in the middle. So I just do the workout. 4 squared is 4 times 4. That's what that means, which is 16. And then over here you have 5 times 4, which is 20. So you have 16 plus 20, which equals 36. So when x is 4, your answer comes to 36. So over here, what you would do, and I like this example because it gives you a negative, what to do when you see a negative. So you have negative 3 substituted for x squared plus 5 times negative 3. Now this is tricky right here, and that's why they put this example in here. Well, what happens when you have a negative squared? It depends how the negative is represented. Here, it is the entire negative 3. So that means negative 3 times negative 3. 2 negatives equal a positive when you multiply. And so negative 3 times negative 3 is 9. Plus, and now you have positive 5 times a negative 3. That's a negative times a positive. Those are different signs, so your answer is a negative answer, a negative product. And 5 times 3 is 15. So here we have, again, integers with your positive and negative numbers, but an integer addition problem. So positive 9 plus negative 15. So a recap of the rule, if you're adding integers, positive and negative numbers, what you do is you're going to actually do the opposite and subtract. So you're going to look at the absolute value of each number, really just taking the number itself. So I'm looking at the 15 and I'm looking at the 9, and I'm saying 15 minus 9 is 6. But because we're dealing with the negatives, and the reason we did the opposite, part of that rule is we have to go back and take the sign of the bigger number. Well, the bigger number is 15, and so here I add a negative 6 on there. So when x is negative 3, my end result is negative 6 for that expression. And so what I do say is if you have problems with positive and negative numbers, be sure to always use a calculator whenever possible. Use the big work in your head of the process. Let the calculator do that type of work for you, just doing the computations. So the reason we have that warm-up is we go on here to where it says generate ordered pairs for the function y equals x squared plus 2 with the given domain, and then they give you this right here as a given domain. Now, remember what this looks like. Let me erase a few things here and make some room. So what this looks like here, I'm going to change colors. Remember when you have D and then a colon, and then you have a set within here, an ordered list, and they're saying this is your domain. Well, my question would be, what does it even mean, domain? Well, they're giving us a chart here, a table here that has x and y. And so I would go and say, well, it's either my x values or it's my y values. So quick quiz, domain represents which, your x or your y? If you said x, then you are correct. Your domain or your input value for a function is here. So when they give it to you in this list, you're just going to do put those numbers into the boxes just the way they are. You had a -2, a -1, a 0, a 1, and a 2. Now that they have given me the domain, they're actually wanting me to find y, which would be considered the range, okay? And so how would I find the corresponding y value or range? Well, it says I have to generate them according to this function. And so this function or function rule here says y equals, and that's what I'm looking for, what does each y equal? X squared plus 2. That's it. So I can remember x squared plus 2. Now what I want to do on this one, if you're very good with math, you can use a little bit of mental math. If you're not, then you want to go ahead and write out each step. The first one I'm going to write out each step, and then each of the others I'm going to show you how to do with mental math. So the first one I'm looking at substituting is this -2 because that's the first one on the list. What if x was -2 and we were substituting there? Well, instead of x squared, that means -2 squared. And then here, that plus 2 kind of tags along. Now we have to do the work. Remember, we just saw a problem like this where -2 squared means -2 times -2. -2 times -2 is +4. Remember, the product of two negatives or same sign is positive. Bring down here my plus 2, and that equals 6. So when x squared plus 2 and x is -2, your corresponding y value is 6. So I would put 6 right there in that box. That's how I would do that problem. Now, remember I said in the first warm-up, sometimes you have to do it for as many x values that are given. And again, look here, we have 1, 2, 3, 4 more x values. So we have to do this 4 more times to complete this table and to begin to graph on a graph what this would look like. Now, what I said is let's take a look at this using mental math. So I have y equals x squared plus 2. What I do is I put in my head, if x was -1, and I pop that -1 in my head and I say, well, -1 squared would be -1 times -1. Well, that makes +1. Then I add plus 2, +1 plus 2 is 3. So I go ahead and put in a 3. What if it was 0? Well, 0 squared is 0, plus 2 is 2. What if x was 1? 1 squared is 1 times 1 is 1, plus 2 is 3. You notice I'm going 6, 3, 2, 3. And since we're working with quadratic functions, I can kind of tell you, do you see a pattern where they're kind of coming down in a constant fashion? And I would imagine that this next number would be a 6 if it was a continuous pattern and it was to make a quadratic function, okay? And so here, I would say this is a quadratic function because it is written in standard form. So I can almost say I know this last number is 6. I want to go ahead and double check just in case. So if x was 2, and I said 2 squared, 2 times 2 is 4, plus the 2, it is in fact 6. It's kind of a helpful little cheat or hint or tip or key, however you want to take it. But I do want to caution you, when you do take steps and you start to recognize patterns, make sure you're on the right pattern. You don't want to go too fast and make unnecessary mistakes. But if you are very good with your math and you think you can go ahead and make those judgment calls and do the mental math, go for it. It's worth it. Okay, that's the warm-up, and then you can go on to the next video where we start the next section having to do with graphing these, finding the vertex, and then finding their minimum and maximum values.